What is the 489th digit in the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, all of that. Nice question, beautiful question. First of all, there's a bunch of one digit numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. Then two digit numbers 10, 11, 12, 13, 14, 15, 16 till 90 till 99. Then three digit numbers 100, 101, 102, 103. Right? So let's track them by digits. And so first we do 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we do 10, 11, 12, 13 all the way till 99. Then we think about 100, 101, 102 up to some point. Why am I saying some point? Because 489th digit. And so maybe we don't go to 4 digits. Okay. So how many digits are involved here? 9 digits are involved here till 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12 till 99. How many digits get accounted for? Each of this is a 2 digit number. How many such are there? 92 digit numbers are there. 10 to 99. 90 into 2, 180. Then we go to 3 digit numbers 101 all the way till 999. 900 3 digit numbers are there. Each of them gives us 3 digits. 900 into 3 is 2700. If we go till 999, another 2700 digits are going to get accounted for. Definitely not going to that level because we're worrying about the 489th digit, not the 2700 plus 180 plus 9, not that large. Right? So what do we got here? Till this point, 189 digits get accounted for. We want to get the 489th digit. 189 go away, or we want a 300th digit in this sequence. Each number gives us 3 digits. 300th digit will be the last digit of the 100th number in the sequence. 100, 101, 102, 103, 104, 105, 106, 107, 108. If you write that down, the 100th number in that sequence, the last digit will be the 300th digit. The 100th 3 digit number is 199. Last digit is 9. 100th 3 digit number is not 200. 101 to 200 is 100 numbers. 100 to 200 will be 101 numbers. 100 to 199 is 100 numbers. The 100th 3 digit number is 199. The 300th digit, when you arrange all the 3 digit numbers from 100 to 199, is the last digit of 199, which is 9. The average of 3 numbers P, Q and R, P, Q, R, average is K. P is as much more than the average as Q is less than the average. And so, what is the value of R? P is as much more than the average as Q is less than the average. So, whatever P brings more than the average, Q offsets it. So, P and Q average is the same average K. That means the third number R should be the average itself. Freebie. And so, if average is K, P is here, Q is here. P and Q, whatever P brings more than average, Q brings less than average. So, if you add both of them, they come back to the same average, which means the third number should be equal to exactly the average. Okay, done. P and Q walk along a circular track. They start at 5 a.m. from the same point in opposite directions. One guy goes like this, one guy goes like this. P walks at an average speed of 5 rounds per hour and Q walks at an average speed of 3 rounds per hour. 5 rounds per hour, 3 rounds per hour. So P can complete a round in 12 minutes, R can complete a round in 20 minutes. P lap time is 12 minutes, R lap time is 20 minutes. Nice. So their speeds are in the ratio opposite of this, the lap time. So P is to Q, speeds is 5:3. 20:12, 5:3. The guy who has the shorter lap time is walking quicker. The longer lap time is walking slower. Their speeds are in the ratio of 5:3. Right? Nice, lovely. Now we need to figure out how many times will they cross each other between 5:20 a.m. and 7 a.m. Let's see when they will meet. Both start at 5 o'clock. This guy goes like this. By 5:12, he'll be back here. By 5:20, this guy will be back here. Somewhere they'll meet. Right? Where will they meet? They'll meet at a point such that the time taken for Q to reach that point, time taken for P to reach that point are both same. Right? Their speeds are in the ratio of 5:3. That means the distance covered should also be in the ratio of 5:3 where they're meeting. So if you say, hey, this is 5x, this is 3x for them to meet. Nice. How much time will they take to meet there? P travels 5/8 of a lap, Q travels 3/8 of a lap. How much time will they take? P will travel for 5/8 into 12 minutes. Q will travel for 3/8 into 20 minutes for them to meet. 5/8 into 12 is 5 into 3/2, 7.5 minutes. 3/8 into 12 is 3 into 5/2, 7.5 minutes. Obviously, this has to be same. They meet. I'm just verifying this. I know these two have to be same. P takes 7.5 minutes to reach this point. Q takes 7.5 minutes to reach that point. Both of them meet once every 7.5 minutes. And this is where it gets interesting. So between 5:20 and 7 a.m., they start at 5. And then so after 7.5 minutes, they'll meet. After 15 minutes, they'll meet. After 22.5 minutes, they'll meet. After 30, they'll meet. 37.5, they'll meet. 45, they'll meet. 52.5, they'll meet. Again at 6 a.m., they'll meet. And then 7.5 minutes past 6, 15 minutes past 6, 22.5 minutes past 6, and so on. And so from 5:20 to 7 a.m., how many times do they meet? These two are out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 times they'll meet. It's a very dicey question. I hate these questions for one reason. These two will definitely meet at 7 a.m. And 7.5, 7.5, 7.5. 7.5 into 2 is 15. 15 into 4 is 60. So in an hour, they'll meet 8 times. And if they meet at 5 a.m., they'll meet at 6 a.m., they'll meet at 7 a.m. They'll meet at standard points, a nice multiple of 7.5 is a factor of 60 minutes. All works out beautifully. Do we need to count that 7 a.m. meeting or not? Because how many times will they cross each other between 5:20 a.m. and 7 a.m.? Saying between 5:20 and 7, the boundaries are not included, and the 7 a.m. time is not included. So we should not count this. And so 1, 2, 3, 4, 5, 1 plus 6 o'clock to 6:52 plus 8, 13 times they'll meet. Right? So not 14. But this is one of those questions where examiners sometimes give the answer as 14. And they say, look, 5 to 7, from 5 o'clock to 7 o'clock, they meet at 7 o'clock. If I say I'm meeting you at 7 o'clock, then am I not meeting you at 7 o'clock? And so they don't look at having the nuance behind this adjective. It's a pain. Right? So I don't like these questions because the borderline thing in my head, between 5:20 a.m. and 7 a.m., we should not count 5:20 a.m., we should not count 7 a.m. Luckily for us, the 5:20 does not cause any confusion because they're not meeting there at exactly 5:20, but exactly 7 a.m. they meet. Do we count that or not count that? My view is that we shouldn't count that, right? But we don't know. And so we used to have categories of questions. One of our professors used to say, look, oh, there's this, we all went with him and said, look, how do we interpret this and what is the meaning of this? He said there are 3 types of questions. One is normal questions. and then they have EOK and GOK. Normal questions we all get. You try, you answer, you solve, you mark an answer choice, plus 3, minus 1, whatever system, all good. EOK is examiner only knows. God knows what that guy thought of when he put 7 a.m. that boundary number there. Was he really, did he just overlook it and put some 2 times? He didn't understand, he didn't pause and process that 7 a.m. is a bone of contention. Did he realize, did he pause and then said it is between 5:20 and 7, we should not count 7? Or did he say 5:20 to 7, 7 o'clock should be counted? We don't know, right? So, examiner only knows. Sometimes examiner also doesn't know. God only knows, right? So, this is one such thing. I don't care for these questions, but hey, we'll have to live. If I have to answer this question, in all honesty, if there's a gun to my head, I'll mark the answer as 13. But I hate that the fact that 7 a.m. ambiguity is sitting inside this question. A natural number n is such that it can be expressed as n equal to p plus q plus r, where p, q, r and r are distinct factors of n. How many numbers below 50 have this property? So, natural number n, so let's think about this. 1 has only one factor, 2 has factors 1 and 2, 3 has factors 1 and 3, 1 plus 2 is not 2, 1 plus 3 is not 3. We need to get a sense of this, where this is headed. Sum of the 3 factors should be equal to n. One of the factors of any number is going to be the number itself. That we cannot add. 1 and the number itself are 2 factors. If we add the number, then the sum of those 3 factors will become more than the number, and more than n. So, p, q, r, none of this can be n, starting point. Right? Any prime number is going to have only 2 factors. All prime numbers are out. So, we don't have to worry about prime numbers. We don't have to worry about any number that has fewer than 3 factors. So, prime numbers are out straight away. Right? Now, let's jump in and keep building on this. So, 1, 2, 3, we don't have to worry about. Let's go to 4. 5, we don't have to worry about. Let's think about 6. 7, we don't have to worry about. 8, 9, 10, 12. We'll see if something falls in place. 4 has factors 1, 2, 4. 1 plus 2 is just 3, not 4. So, 4 is also not in. 1, 2, 3, 4 are all out. 6 has factors 1, 2, 3, 6. 1 plus 2 plus 3 is 6. So, 6 can work. 1 plus 2 plus 3. 1, 2, 3 can be the 3 factors adding up to 6 itself. Right. 8 has factors 1, 2, 4, 8. Does not work adding up any 3. 8 we cannot add. Forget about 8. From now on, I'm going to skip the number itself as a factor. That we'll ignore. So, 1, 2, 4 adds up only to 7, ruled out. So, 1 and 3 adds up to 4, ruled out. This is out, this is out. 10, 1, 2, 5, not big enough, out. 12, 1, 2, 3, 4, 6. And then 12 itself, I'll ignore 12. 1, 2, 3, 4, 6. 1 plus 2 plus 3 is 6. 6 plus 6 is 12. Or 2 plus 4 plus 6 is 12. So, 2 plus 4 plus 6, that combination, only because we need only 3 numbers adding up. 2 plus 4 plus 6 adding up to 12 works. 12 works. 6 works. Nice. 13 we don't have to worry. 14, I'm going to go to 14. 1, 2, 7 doesn't come. 15, 1, 3, 5, no problem. 16 is a power of 2, done this. 1, 2, 4, 8, we add that will add up to 15. So, all powers of 2 we can ignore, all prime numbers we can ignore. So, from now on I'm going to, these two are out, 16 is out, 32 is out, 17 is out, 18. 18 has factors 1, 2, 3, 6, 9 and then 18 itself. Can we have some 3 numbers adding up to this? 3 plus 6 plus 9 is 18. That works. 3 plus 6 plus 9 is 18. So, 18 also gets counted. So far, we have numbers 6, 12 and 18. There's some pattern here, very nice, simple. 6, 1, 2, 3 are factors of 6. 6 into 2 is 12. Any factor of 6 into 2 will be a factor of 12. So for 6, we added 1, 2, 3. For 12, we could add 2, 4, 6. For 18, we could add 3, 6, 9. So 6 works, 12 will work, 18 will work, 24 will work, 30 will work, 36 will work, 42 will work, 48 will work. What are the three factors of 48 that add up to this? 1 into 8, 8, 2 into 8, 16, 3 into 8, 24. And so any number n, which is a multiple of 6, n by 6, n by 3, n by 2 will be factors of n. N by 6 plus n by 3 plus n by 2 is equal to n. So multiples of 6 work. Prime numbers don't work. Powers of 2 do not work. So far multiples of 6, all of them have worked. We have to see if some other number will work. And so till 18, we have nothing to worry about. We've covered everything. 19 is out. I'm going to think about the numbers remaining. 20, 21, 22, 24 is already in, 25. I'm going to see whether I can get close to that. 20 factors are 1, 2, 4, 5, 4 into 5, 2 into 10, 20 I'll ignore. To add 3 factors up to this. 10 plus 5 is 15, 19, 20. 4 factors adding up to 20 is possible. 3 factors adding up to 20 does not seem to be happening. 2 plus 4 plus 5 does not work. 10 plus 5 is 15. That doesn't work. So 3 factors adding up to 20, not possible. Close, I thought was happening, not happening. 21 is 1, 3, 7. 21 I'll ignore, not happening. 22, 1, 2, 11, not happening. I'm thinking there are only 2 prime numbers. So not 2 and 3, 2 and 7, 2 and 11, 3 and 7. Then we'll have numbers 1, p, q. 1 plus p plus q being equal to pq. 1 plus 2 plus 3 is 6. But I don't think anything else is possible. 1 plus 2 plus 5 is only 8. 1, 2 into 5 is 10. Right, so I'm thinking 2 into 3, that number will work. 2 into 5, 2 into 7, 2 into 11, all of these are not going to work. 2 into 7 is 14. 1 plus 2 plus 7 is not 14. Right, so 1 plus 2 plus 3 is 6. There it works. 1 plus 2 plus 7 is 10, whereas 14 is larger. Right, so 2 into 5, 2 into 7, 2 into 11, I don't need to worry about these numbers. Another set of numbers that are out. 3 into 5, 3 into 7, 3 into 11, they're all out as well. Let's keep doing this. 25 is 1, 5 and 25 not working. So any prime number square of a prime, the factors are 1 p, p square. P square is out. 1 and p cannot add up to p square. Square of a prime is out. Product of 2 primes except 2 and 3, that is out. So I'm getting better at this. 26 is out. 26 is out. This is out. This is out. Out. 27 factors are 1, 3, 9, 27. 27 we'll rule out. 1, 3, 9 don't add up. Powers of 3 cannot reach 3. That's also out. 28. 28 could be interesting because it doesn't get eliminated anywhere here. 1, 2, 4, 7, 14. 28 itself is ruled out. 14 plus 7, 21. 25. These the 3 largest factors add up to 25. If I add all of them, it becomes 28. So 28 is what is called as a perfect number. Sum of all factors of 28 except 28 itself adds up to 28. It's called a perfect number. It's a perfect number but doesn't satisfy our condition. In our case, n should be a sum of 3 factors of n. Not all factors, not many factors, not 3 or more. Exactly 3. So 28 also doesn't work. 29 doesn't work, we know. 30 is already in. 31 doesn't work, prime number. 32 doesn't work, power of 2. 33 doesn't work, 3 into 11. 34 doesn't work, 2 into 17. 35, 5 into 7, no. 36 is already in. So I'm going to go back and say, hey, 36 is in. Let's go back to say 37 is out. 38 is out. 39 is out. 2 into 19, 3 into 13, 2 primes spread out, doesn't work. 40 could be interesting. So I'll keep 40 in my list. 41 doesn't work. 42 is already in. 43 doesn't work. 44, I'll have to think. I'm reasonably sure it won't come, but I'm going to stick this in. 45 will work. We'll have to think about 45. 46 won't work. 47 won't work. 48 is already in. 49 won't work. Fine. Below 50. It's only these three we need to really evaluate. 40 factors are 1, 2, 4, 5, 5 into 8, 4 into 10, 2 into 20, and then 40 itself. 20 plus 10, 30 plus 8 is 38. You need 40. Close, but no cigar. So 40 doesn't work. The three largest factors add up to 38. So nothing else will work, that I know. So 40 won't work. 44 factors are 1, 2, 11, 22, 1, 2, 4, 11, 22, 44. 44 we'll ignore. 22 plus 11 is 33, plus 4 is 37. Three largest factors apart from 44 don't add up to 44. This also doesn't work. 45 is 1, 3, 5, 9, 15 and 45. 15 plus 9, 24 plus 5, 29. Doesn't go to 45. Three largest factors don't work. Get out. So what we have here is quite beautifully all multiples of 6 and only multiples of 6. And so beautiful, wonderful idea. So therefore now we can say only multiples of 6 work. 6, 12, 18, 24, 30, 36, 42, 48. 8 multiples of 6. Answer is 8. Wonderful. Now I'm going to tweak this to see if we can do this mathematically. And so n is p plus q plus r. We have seen that, hey, n by 2, n by 3, n by 6, these three add up to n. We know. Right? So I'm going to see if no other combination exists. Right? So hypothetically, if n were an even number, n by 2 will be a factor. If n were not an even number, n by 2 is not a factor. So if you're thinking about 45 or 69 or 87 or 81, then half is not a factor, half of that number. Right? So the largest factor of n will be n by 3. Leaving out n itself, we cannot include n, that we know. Leaving out n itself, the largest factor of odd number n, largest possible factor is n by 3. And then there are two other factors. And so after n by 3, two numbers less than n by 3. If we add them, we cannot get n. N by 3 plus n by 3 plus n by 3 is n. So if n by 3 were there, then other two numbers being less than n by 3, adding up to n itself is not possible. So n cannot be odd. N has to be even. If n is even, then, and we are thinking about factors of n, right? So then we know for sure that n by 2 is a factor and it has to be included in our list of three numbers. N by 2 has to be in. Okay? So the other two, these two should add up to n by 2. Nice. Two numbers add up to n by 2. Half of n by 2 is n by 4. N by 4 plus n by 4 can add up to n by 2. But we have been told there are distinct factors of n. So it cannot be n by 4 and n by 4. Not possible. N by 2 is definitely in. So if I break n by 2 equally, I'll have n by 4, n by 4. That's not possible. We've been clearly told that the factors are distinct. N by 4, n by 4 is not possible. So I'm breaking n by 2 into two equal parts. That doesn't work. But if I break n by 2 into two parts that add up to n by 2, one should be less than n by 4, another should be more than n by 4. Nice. One number should be less than n by 4. If I'm breaking an apple into two parts which are not equal, one should be more than half, other should be less than half. If I'm breaking n by 2 into two parts not equal, one should be more than n by 4, other is less than n by 4. More than n by 4, less than n by 2, there's only one factor. N by 2 is there, n by 3 should also be there. n by 2 plus n by 3 is 5n by 6. Remaining should be n by 6. This is a combination that adds up to n. This is the only combination that adds up to n. This is the only scenario where 3 factors exactly can add up to the number itself. That means any number we have, if 3 of its factors adds up to the number itself, then the number has to be a multiple of 6. And all multiples of 6 will have this combination. This question effectively says, below 50, how many multiples of 6 are there? 8 of them are there. Very interesting question. Listing it down based on gut feel, eliminating, taking chances, we can attempt it. And then we can go and see very rigorously, very mathematically, why only multiples of 6 will work. If n is a natural number, then what are the number of distinct reminders of 1 power n plus 2 power n when divided by 4? And some of these questions just take care of themselves. What do? I put 1 power n, 1 plus 2 power 1. This is 3. 1 square plus 2 square. Which is 1 plus 4, 5. 1 cube plus 2 cube. 1 plus 8, 9. 1 power 4 plus 2 power 4, 17, and so on. When divided by 4, what is the remainder? When you divide this by 4, the remainder is 3. Remainder is 1, 1, 1. The moment n crosses 2, n is 2 or higher, 2 power n is a multiple of 4. So only 1 power n will give the remainder. 1 power anything is 1. So n greater than or equal to 2, remainder is 1. 2 power 1 power 100 plus 2 power 100 divided by 4, 1. 1 power billion plus 2 power billion divided by 4, remainder 1. This is the other possibility. How many possible reminders are there? Number of distinct reminders possible. 2, 1 and 3. 3 occurs on one instance, 1 occurs on every other instance. 2 possible reminders are there. Let p equal to q be a 3-digit number. So p could be 111 or 222 or 333 or something like that. What are the HCF of p and 481? And so 111, 222, 333 are all multiples of 111. 111 is a multiple of 3. So 111, 111 is 3 into 37. Nice. Or q is q into 3 into 37, where q is a digit. If it is 111, it is just 3 into 37. If it is 222, it is 2 into 3 into 37, 6 into 37. If it is 333, 3 into 3 into 37, 444, 4 into 3 into 37, and so on. What is the HCF of P and 481? My gut feel is 481 is going to be a multiple of 37. So I'm going to divide 481 by 37. So between 481 and Q, 37 is common for sure. So this is 37 into 3Q, that is 37 into 13. What else can be common? Nothing can be common. This is 3 and Q. Q is a single digit number, that is 13, which is a prime number, a 2-digit prime number. Nothing else is common. Highest common factor is 37. There are n sets of numbers, each having only 3 positive integers, with LCM equal to 1001 and HCF equal to 1. Set of numbers PQR, a set of numbers with distinct identifiable elements. So the number should be distinct. HCF is, LCM is 1001 and HCF is 1. Right? But think about this, LCM is 1001. So 1001 is 7 into 11 into 13. And so between P, Q and R, we should have 7 into 11 into 13, and there should be nothing in common overall, and HCF should be 1. And so what can I say? I can put one of the numbers as 1, one of the numbers as 1001. HCF will be 1, LCM can be 1001. I can have the third number as 7, 11, 13, 7 into 11, 11 into 13, 7 into 13. All of these will work. HCF is 1, LCM is 1001. All of these cases. 1, 2, 3, 4, 5, 6. I would say leave out this 1 and 1001 framework. Let's keep 1001 intact and keep one of the numbers as 7. This other number should not have anything in common with 7. But it can have 11. It can have 13. It can have 11 into 13. This will also work. I can put 11, 13, 1001. That will also work. It seems like there are lots of possibilities. 1, 2, 3, 4, 5, 6, 7, 8, 9. Lots of possibilities. I don't need to find out how many are there, but lots are there. That's sufficient for us. 4 less than or equal to x less than or equal to 8 and 2 less than or equal to y less than or equal to 7. What is the ratio of the maximum value of x plus y to minimum value of x minus y? Maximum value of x plus y is very easy, 8 plus 7. Maximum value of x plus y is maximum value of x, maximum value of y. Minimum value of x minus y, take x as low as possible, y as high as possible. X plus y maximum, x minus y minimum. X should be 4, y should be 7. X minus y can go to minus 3 but not lower than that. X plus y can go to 15 but not higher than that. Maximum value of x plus y to minimum value of x minus y is 15 by minus 3, which is minus 5. That's not there, none of the above. Remember, they are not asking us to maximize or minimize x plus y by x minus y. They think take maximum value of x plus y, minimum value of x minus y, find the ratio, which is ratio should be minus 5. That's not there, none of the above. What are the maximum value of n such that 7 into 343 into 385 into 1000 into 2401 into 77777 is divisible by 35 par n? A nice simple question. 35 par n is 7 par n into 5 par n. You have to count the number of 7s in this, number of 5s in this. There are lots of 7s, then 5 will be the limiting factor. Lots of 5s, 7 will be the limiting factor. And so the largest par of 7, how many 7s can go into this, how many 5s can go into this? Lesser of those two is our answer, right? So this gives us 1 7, this gives us 3 7s, this gives us 1 7, this is 4 7s, 2401 is 49 square, and then there's a 7 here also. Seem to be lots of 7s, right? Let's count 5s. There are 3 5s here, 1 5 here, nothing else. I'm not even going to find out how many 7s are there totally. 343 is a power of 7. 2401 is a power of 7, 7 cube, 7 power 4. Lots of 7s. There are only 2 multiples of 5. 1000 is 2 cube into 5 cube, 3 5s. 385 is 5 into 7 into 11, 1 5. There are only 4 5s, lots of 7s. Right? So what am I counting here? 7s in the system. What are we counting here? 5s in the system. What do I mean by that? If I multiply all of this, 7 par watt will be sitting inside that. 5 par watt will be sitting inside that. Sitting inside this whole product is 5 par 4 and 7 par a large number. And so 1 plus 3 plus 1 plus 4 plus 1. I am not calculating that. I don't need to because it is higher than 4. But I know there are only 4 5s. So largest value of n such that 35 par n is a factor of this number is 4. If I put 35 par 5, I'll have to have 5 par 5 sitting in the numerator, sitting in this number. That's not available. I have lots of 7s, but fewer 5s. So I need to worry about only how many 5s are there. Consider the first 100 natural numbers. How many of them are not divisible by 1 of 2, 3, 5, 7 or 9? Right? So very interesting. 2, 3, 5, 7 or 9. Right? So first of all, if it is not divisible by 3, it's not divisible by 9. Right. The number not a multiple of 3, how can it be a multiple of 9? Not possible. So it's not a multiple of 3, not a 2, 3, 5 or 7. I want to think about numbers that are not multiples of 2, 3, 5 or 7. Very interesting. First of all, the first number 1 will be in the list. 1 is not a multiple of 2, 1 is not a multiple of 3, 5, 7. Right? That's the number that will be in the list. Apart from this, we say, hey, 2, 3, 5, 7. What other numbers are definitely on this list? Prime numbers will all be on this list. Prime numbers are not multiples of anything apart from 1 and itself, 1 and themselves. So, all prime numbers will be in this list. Right? Very interesting. So, I am going to write down all prime numbers. 2, 3, 5, 7 are already there. Start with 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. I know this, you should be comfortable with this. I also know that there are below 100, there are 25 prime numbers. We leave out 4 of this, there should be 21 remaining. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 prime numbers are there, less than 100, leaving out these 4 fellows. All 21 of them will get counted, plus this one, 22 numbers are in the bag. Right? Now, is there, what other numbers will come apart from prime? Right? So we want a number that's not a prime number, right? And not a multiple of 2, 3, 5, 7. Right? So 2, 3, 5, 7 are prime. Right? So if you take a number like say 69, 3 into 33, 23, that's out, I can't include it. If I take a number like 57, 3 into 19, no. If I take any even number that's a multiple of 2, I cannot count. So I want numbers, all prime numbers I have counted, 1 I have counted, these are numbers in my list. Apart from this, is there a number in our list? Apart from this, I am thinking about composite numbers, not 1 is not composite numbers that are not multiples of 2, 3, 5, 7. Any composite number is a combination of primes. 2, 3, 5, 7 are not included, the next prime is 11. So, it is 11 into 11, 11 into 13, that number will become more than 100. None of those we need to count. Any number less than 100 is either prime or it's a multiple of 2, 3, 5, 7 or 1 itself. We cannot forget 1. So, 21 prime numbers apart from this plus 1, so 22 numbers. N square equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. How many digits does the number n have? So, it's a nice interesting question. Think about it. 11 into 11 is 121. 111 into 111. If I multiply 111, 111, 111. This will be 1, 2, 3, 2, 1. 1111 into 1111, 1111, 1111, 1111, 1111, 1, 2, 3, 4, 3, 2, 1. Nice. Or this number is nothing but 1, 1, 1, 3, 4, 5, 6, 7, 8, 9 into 1, 1, 1, 1, 1, 1, 1, 1, 1. If I do this, I'll have 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Then one more step. I'm sure you don't want me to do this all the way. But if we add all of that up, you should get 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. It's a nice palindrome of a number. 11111 9 times into 11111 9 times. That number square is this. How many digits does the number n have? 9 digits. How many possible values of p plus q plus r are there satisfying 1 by p plus 1 by q plus 1 by r is equal to 1, where p, q, r are natural numbers, not necessarily distinct. Oh, very interesting. And not necessarily distinct, very powerful. The numbers are not distinct. How do I do? Very nice, simple. I'll say let them not be distinct. Let me put all of them are equal. 1 by 3, 1 by 3, 1 by 3. 1 by 3 plus 1 by 3 plus 1 by 3. 1/3 plus 1/3 plus 1/3. That works. Brilliant. I'm very happy. So 1 by 3 plus 1 by 3 plus 1 by 3 adds up to 1. That is one possibility. Straight away, all are equal. So you solve for this, all of them being equal. Now we need to add layers to this. Right? So PQR cannot be 1. 1 by 1 will itself become 1. There is a room for 1 by Q, 1 by R and all that. None of them can be 1. So PQR are starting from 2 onwards. Right? So 1 by 3 plus 1 by 3 plus 1 by 3 is a nice obvious solution. We take it, put in the bag. Then we say, hey, let us start step by step. Let's start with one of the numbers being 1 by 2. The other 2 should add up to half. Right? One obvious solution for other 2 adding up to half, put them equal, 1 by 4, 1 by 4. Nice. Half plus 1 by 4 plus 1 by 4. And take 1 by 2 into the mix. Remaining 2 should add up to half. So with 1 by 2 in, the other 2 can be equal, 1 by 4, 1 by 4, done. That's one possibility. Now, if you put this as 1 by 2 and think of possibilities beyond this, half broken into 2 equal parts is quarter and quarter. That we have counted. Half, 2 parts adding up to half, not quarter and quarter. One should be less than 1/4, other should be greater than 1/4. Same funda. If you have an apple, you break it into 2 equal parts, half an apple, half an apple. If you have an apple, you break it into 2 parts that are not equal. One should be more than half, other should be less than half. So half is remaining, that is broken into 2 parts, not quarter and quarter. One should be more than 1/4, one should be less than 1/4. More than 1/4, only one possibility is there, 1 by 3. 1 by 2 plus 1 by 3 is 5 by 6. 3 by 6 plus 2 by 6, 5 by 6. So 1 by 2, 1 by 3, 1 by 6 is a possibility. 1 by 2, 1 by 4, 1 by 4 is a possibility. 1 by 2, 1 by 3, 1 by 6 is a possibility. Nothing else is possible because more than 1/4, only one possibility is there, 1/3. If you put half, it will be half, half and 0. That's not possible. 1 by something cannot be 0. So if one of the numbers were half, that is 1 by p is half, p is 2. Then we have 2 possibilities and only 2 possibilities. 1 by 2, 1 by 4, 1 by 4. 1 by 2, 1 by 3, 1 by 6. So with p equal to 2, we've got all solutions. When we put p equal to 3, this jumps out 1 by 3, 1 by 3, 1 by 3. Straight away we think, is there any other solution possible after this? 1 by 3 is in, the other 2 numbers should add up to 2 by 3. 1/3, 1/3 is a possibility. If I do beyond it, one number should be more than 1/3, other number should be less than 1/3. More than 1/3, only half is there. Half I have already counted. So leaving out 1 by 2 out of the picture, right? Then there's only one solution with 1 by 3 in it. 1/3, 1/3, 1/3. Now I have counted everything with 2 in the picture, with 3 in the picture. We go beyond this. So PQR not equal to 2 or 3. Everything with 2 we have counted. Everything with 3 we have counted. All 3 are not equal to 2 or 3. We put even 4, 1 by 4 plus 1 by 4 plus 1 by 4 doesn't add up to 1. 1 by 4 plus 1 by 4 plus 1 by 4 is only 3 by 4. Without 2 and 3, we simply cannot do it. Impossible. With 2, we have counted everything. With 3, we have counted everything. With 4, without 2 and 3, with only 4s, 5s and 6s, we cannot do this at all. Or how many solutions are there? Totally 3. A beautiful idea. If 3 parts add up to k, k by 3, k by 3, k by 3 is a possibility. Nice, beautiful possibility. We cannot have 3 numbers all more than k by 3 adding up to k. We cannot have 3 numbers all less than k by 3 adding up to k. Seems like a very bleeding obvious thing to say. Right? So if you have some 1/3, 1/3, 1/3. 1/3 plus 1/3 plus 1/3 is a whole. 3 fractions all less than 1/3 cannot add up to a whole. 3 fractions all more than 1/3 cannot add up to the whole. And so some seems very bleeding obvious, but it's using this here. 1 by 4 plus 1 by 4 plus 1 by 4 is 3 by 4. So if I'm adding 3 numbers to 1, at least one of them has to be 1 by 3 or more. A very interesting idea. 1 by 3, 1 by 3, 1 by 3, if you have evaluated, to kick that out. After that, we can say one of the numbers has to be more than 1 by 3 for sure. We can also say one of the numbers has to be less than 1 by 3 for sure. All three equal, we have counted. So, with that in mind, we can anchor and say 4, 4, 4, 5, 5, 5. If you remove 2 and 3 possibilities, know that we don't have to worry about anything else. Right? So, 3 possible outcomes. There exists a natural number which, when increased by 50%, can have its number of factors unchanged. A natural number which, when increased by 50%, the number of factors remains unchanged. And so, very interesting. So, 2n has some number of factors, 3n also has the same number of factors. And so, 2n to 3n is a 50% increase. Is this possible? Very much possible. This has 2 as prime factors, as 3 as a prime factor. If I can think the number of factors of a number depends on the prime factorization. So, hypothetically, if I have a number n that has no 2's and no 3's, I take n equal to 5, 2 into 5, 3 into 5. These two numbers will have the same number of factors. This is 2 into n, that is 3 into n. So, 2n and 3n have the same number of factors, very much possible. And so, this tells us that n, if n had no 2's and 3's, it could be 5 into 7, it could be 5 cube into 7 square, it does not matter. 2n and 3n will have the same. Or even possible that they have the same number of 2's and 3's. So, 2 into 6 and 3 into 6 will have the same number of factors. 2 into 6 is 2 square into 3. 3 into 6 is 2 into 3 square, same number of factors. If n has the same number of 2's and 3's, it could also be 0, then 2n and 3n will have the same number of factors. So, is this possible? There exists a natural number. Oh, I already found one, 5 exists. This is true. There exists a natural number which, when increased by 150%, can have its number of factors unchanged. Yes. So, now we are talking about 2k and 5k. 2k and 5k have the same number of factors, very much possible. 2 into 3, 5 into 3. This is 6, this is 15, same number of factors, both have 4 factors each, that is also possible. This tells us that k has an equal number of 2's and 5's sitting inside it, which could be 0. And so, k could be 7, 2 into 7, 5 into 7, same number of factors. K could be 11, k could be 7 square into 11 cube, does not matter. These two will have the same number of factors. So, both of these statements are true. Both 1 and 2. The petrol price shot up by 10% as a result of the hike in crude oil prices. The price of petrol before the hike was 90 per liter. A person travels 2,200 kilometers every month and his car gives a mileage of 16 kilometers per liter. By how many kilometers should he reduce his travel if he wants to maintain his expenditure at previous level? And so, there is price, there is distance traveled, and there is mileage. So, petrol price shot up by 10%. So, the price was originally P, it went to 11p by 10. 1/10 increase, 11p by 10. Right. Now, because of this, the distance he can potentially travel, he wants to maintain his expenditure at the previous level. Right. So, his price has gone up 11p by 10. The distance traveled he is shrinking so that his expenditure is the same level. Right. So, his budget is fixed. Right. For that budget, he has to travel lesser distance. Right. What is budget? Price, instead of distance, I am going to now think about quantity. At a price of P, he takes Q liters. If price goes to 11p by 10, how many liters of petrol can he buy? Then we will go to distance. And so, This is 11p by 10. It should become 10q by 11. P into q is pq. This into 11p by 10 into 10q by 11 is also pq. So, if my budget is the same, if my price of petrol goes up to 11 by 10, the quantity I am buying should go down to 10 by 11. 11 by 10, 10 by 11 multiply to give me 1. So, whatever quantity of petrol I was buying, now I will be able to buy only 10/11th of that. Now, forget this equation, come to the next one. Quantity that was bought was some q. Now it is 10q by 11. Distance traveled was d. Distance traveled will be 10d by 11. Whatever original distance I could travel, I'll able to travel 10/11ths of that. I was able to travel 2200. Now I'll be able to travel 2200 into 10 by 11, which is 2000. Or I was able to travel 2200. Now I can travel only 2000. By how many kilometers should he reduce his travel? He should reduce his travel by 200 kilometers. Nice question, because this number 16 kilometers per liter is irrelevant. You don't need that. This number rupees 90 per liter is irrelevant. Price goes to 11 by 10, quantity will go to 10 by 11. Quantity of petrol, because budget is same. Quantity of petrol goes down to 10 by 11. Distance travel, distance that he can potentially travel will reduce to 10 by 11. He was traveling 2200, now he can do 2000, difference is 200. He has to cut short his distance traveled by 200 kilometers. Let PQR be a 3-digit number, PPT be a 3-digit number, and PS be a 2-digit number, where PQRST are distinct non-zero digits. Distinct is important. Distinct non-zero digits. Further, PQR minus PS is PPT. PQR minus PS is PPT. Okay. So this P comes directly here. So there's no carryover, no borrowing at Q. So Q is greater than or equal to P. And RST, let's think about this. If Q is 3 and T is less than 6, what are the number of possible values of R comma S? Q is 3, so let's write this down. P3R, PS, PPT. Lovely. Now P is less than 3, that much we know. If P were 2, this will also have to be 2. 3 minus 2 cannot be 2. P were 1, this will have to be 1. 3 minus 1 can be 1 if you have borrowed something. P is not 0, distinct non-zero digits. So P has to be 1. And so from this, P is, both of these are P. P is less than Q because there's no borrowing involved. Because if we borrowed here, this won't be P. So 3 minus P gives us P. It may be 3 minus P gives us P or 2 minus P gives us P. It cannot be 3, it has to become 2. There is a borrowing involved here. This becomes 2. This becomes 10 plus R. And this is 2 minus P is P, or P is 1. So this now becomes 1 3 R minus 1 S is equal to 1 1 T. And 130 something minus 1 S gives us 111, 110 something. And so T is less than 6 and Q is 3. So we can say S plus T equal to 10 plus R. We borrow, it becomes 10 plus R. 10 plus R minus S is equal to T. S plus T equals 10 plus R. That's like an equation, very simple one. T is less than 6, T could be 5 or etc. etc. R is not 0. R cannot be 1 because P is already 1. R cannot be 3 because Q is 3. R could be 2. So we could put R as 2. So 10 plus 2 is S plus T. S plus T should be 12. 6 plus 6 is ruled out. 5 plus 7 is possible, not 5 plus 7, 7 plus 5. Which will make, we have already covered PQR as 1, 3, 2, 7 and 5, this could work. could be 8 plus 4 is 10 plus 2, that will work. 9 plus 3 will not work because t will have to become 3. They are distinct digits. 3 is not possible. So, what else could r be? R cannot be 3, r could be 4. If r were 4, s plus t is 10 plus 4, 14. 9 plus 5 is 14. This is the only possibility because t is less than 6. T can be 5, 4, 3, 2, 1. T were 5, s would be 9. If t became 4, s would have to be 10. That's not possible. It's a digit. So 9 plus 5 and 10 plus 4. Yeah, 9 and 5 being s and t, r being 4, 1, 3 already taken. That works. R being 2, s and t being 7 and 5, 8 and 4. That also works. How many possible values of r comma s are there? It could be r2 s7, r2 s8 or r4 s9. Three possibilities are there for r comma s: 2 comma 7, 2 comma 8, 4 comma 9. Excellent question. The 5-digit number PQRST, all distinct digits, is such that t is not equal to 0. The last digit is not equal to 0. P is thrice t. Okay. So this is 3t, q, r, s and t. S is greater than q by 4. S is q plus 4. 3t, q, r, q plus 4, t. While q is greater than r by 3. Okay. So this is r. This is r plus 3, r plus 7, this plus 4, t, 3t. We managed to capture this with just two variables. Maybe it will just become one. How many such 5-digit numbers are possible? Oh, nice. T, 3t, r plus 3, r plus 7. Beautiful. Now t and t, 3t, t is not 0. T is a single digit number, 3t is a single digit number. And so t and 3t could be 1 and 3, 2 and 6, 3 and 9. If it goes to 4, this will become 12. Not possible. R plus 3, R plus 7. R is a digit. R plus 7 is also a digit. And T is not equal to 0. R can be 0, S can be 0, Q can be 0. So this could be 0 and 7, 1 and 8, 2 and 9. It cannot go beyond that. We become a 2-digit number. So 0, 3, 0, 3, 7, 1, 4, 8, 2, 5, 9. These are the combinations here. These are the combinations here. 3 sets of possibilities here, 3 possibilities here. I cannot say 3 into 3, 9 because I know that P, Q, R, S, T are all distinct digits. Right? So we'll have to say, hey, nice, interesting. If T or 3T were some digit, that cannot feature here. So what am I going to do? I'm going to say, hey, let me select this and then think about what combination from here will work for each of those. If T were 1, 3T would be 3. I cannot have this sequence, this has a 3. I cannot have this sequence, this has a 1. So if it were 1 and 3, I could have only the 5 to 9 sequence. 5 to 9 for QRS. Nice. Next step is 2 comma 6. There's a 2 here, that's out. But other 2 work. So if it were 2, 6, we could have 3, 0, 7 and 4, 1, 8. Both are possible for QRS. Now we go to 3 comma 9. This cannot come, 3 is already there. This cannot come, 9 is already there. 3, 9, 1, 8. So how many possibilities are there? 4 different possibilities. T and 3T being 1 and 3 and then 5, 2, 9 for QRS. 2 and 6, 3, 0, 7, 4, 1, 8. 3, 9, 4, 1, 8. Super. So how many possibilities are there? 4 possibilities. 1, 2, 3, 4. How many such 5-digit numbers are possible? 4 of them are possible. The price P of a commodity is first increased by k%, then decreased by k%. again increase by k percent, and again decrease by k percent. If the new price is q, what is the relationship between p and q? So p into 1 plus k by 100 into 1 minus k by 100 into 1 plus k by 100 into 1 minus k by 100 is equal to q. If price is increased by k percent, then it goes up by a factor of it goes up to initial price into 1 plus k by 100. If you are increasing by price by 100%, you are doubling the price. 1 plus 100 by 100 is 2. If you are increasing it by 50%, you are taking it to 3 by 2 of what it was, 1.5 times what it was. 1 plus half. After this, it's very simple. So this is p into 100 plus k by 100, 100 minus k by 100, and the same thing repeated. So I'm going to call this square and this square. 100 plus k, there's a k square sitting here. 100 plus k into 100 minus k is 10,000 minus k square. So I'm going to think of this as p into 10,000 minus k square whole square. This into this is 10,000 minus k square whole square equals 100 square into 100 square into q. 100 square into 100 square is 10 power 8. This is 10 power 4. So we can say p into 10 power 4 minus k square is q into 10 power 8. P into 10 power 4 minus k square, the whole square, is q into 10 power 8. 10 power 4 minus k square, that's 10 power 4. These two have only 10 power 4 here. This one does not have a square. P into 10 power 4 minus k square, the whole square, is q into 10 power 8. Let p and k be both prime numbers such that p square plus k is also a prime number less than 30. What are the number of possible values of k? How many values can k take? And so, first of all, prime numbers is only one even prime number, 2. Everything else is odd. If suppose p and k were not 2, p comma k not equal to 2, we keep the 2 aside. Right? P and k be both prime numbers, p square plus k. And so, if p were not 2 and k were not 2, p square will be an odd number, k will be an odd number, p square plus k will be an even number, a large even number, not 2. It cannot be prime. Right? So straight away we can, starting point is either p equal to 2 or k equal to 2. Either p is 2 or k is 2. If p is 2, p square plus k is 4 plus k is prime. What values can k take? 4 plus 3 is prime, k could be 3, 4 plus 3 is 7. 4 plus 7 is 11, yeah, k could be 4. 4 plus 11 is 15, doesn't work. 4 plus 13 is 17, so 13 could work. 4 plus 17 is 21, doesn't work. 4 plus 19 is 23, that works. 23 is prime. 23 plus 4 is 27, doesn't work. 29 plus 4 is 33, doesn't work. 31 plus 4 is 35, doesn't work. 37 plus 4 is 41, that is also prime. 41 plus 4 is 45, doesn't work. 43 plus 4 is 47, that works. Oh, we needed only till 30, oopsie. So, it's also a prime number less than 30. 3, 4, 13, 19, all of them work. So, 2 square plus 3 is prime. 2 square, sorry, not 4, 7. 2 square plus 7 is prime. 2 square plus 13 is prime. 2 square plus 19 is prime. All of these are prime. Right? Now, k is 2, p is prime. So, I am thinking about 3 square plus 2, which is 11. 5 square plus 2, which is 29. 7 square plus 2, we cross over. So these two exist. What is the possible number of possible values of k? K could be 2, k could be 3, 7, 13, 19. 2 plus 4, 5 different values. What is the remainder when 9 cube plus 9 power 4 plus 9 power 5 plus 9 power 6 all the way till 9 power 100 is divided by 6. 9 cube plus 9 power 4 plus 9.5, all of these numbers are multiples of 3. So sum of all of these numbers is a multiple of 3, right? And all of these numbers are odd. There are 98 numbers. So each of them is a multiple of 3. So sum of all of them is a multiple of 3. Each of them is an odd multiple of 3. So there are 98 odd numbers. If you add any two odd numbers, you'll get an even number. If you add an even number of odd numbers, it will be even. An even number, that's a multiple of 3, or it's an even multiple of 3, or it's a multiple of 6. You divide by 6, remainder is 0. Super easy question. A 4-digit number n is such that when divided by 3, 5, 6 and 9, it leaves remainders of 1, 3, 4 and 7 in each case. And so some number n divided by 3, remainder is 1. Some number n divided by 5, remainder is 3. N divided by 6, remainder is 3. N by 9, remainder is 7. Right, very interesting. Right? So very interesting way of writing this. Remainder is 1, or when I divide by 3, remainder is 1. N is of the form 3k plus 1. It's of the form 5p plus 3. It's of the form 6a plus 4. Written wrong. And 9b plus 7. So 3k plus 1, 5p plus 3, 6p plus 4, 9b plus 7. Right? So very interestingly, this remainder 1, 3, 4, 7. If you think about it, remainder of 1 can be thought of as remainder of minus 2. I have a number, I divide it by 3, I get remainder 1. Or it's a number where 1 lesser, it would have been a multiple of 3. Or 2 more, it would have been a multiple of 3. And so you want to think about this number n, which is the form 3k plus 1, 5p plus 3, 6a plus 4, 9b plus 7. You want to say, I'm going to think about n plus 2. N plus 2 will be 3k plus 3, 5p plus 5, 6a plus 6, 9b plus 9. Multiple of 3, multiple of 5, multiple of 6, multiple of 9. 3k plus 3 is a multiple of 3. 5p plus 5 is a multiple of 5. 6a plus 6 is a multiple of 6. 9b plus 9 is a multiple of 9. Or my number beautifully n plus 2 is a multiple of 3, 5, 6 and 9. Or it's a multiple of LCM of 3, 5, 6 and 9. LCM of 3 and 6 is just 6. 6 and 9 is 18. 18 and 5 is 90. Or n plus 2 is of the form 90c. Or n is of the form 90c minus 2. Remainder of, when you divide by 3, remainder is 1. That means that number minus 1 is a multiple of 3, or number plus 2 is a multiple of 3. Whatever our number n, plus 2 is a multiple of 3, 5, 6 and 9. So our number n is of the form 90c minus 2. So the smallest number n that will work is 88. Next is 178. Any multiple of 90 minus 2. So what is the smallest value of n when n is a 4-digit number? 90 into 11 is 990. So 90 into 12 is 1080 minus 2, 1078. I'm doing with this elaborate method because it's useful for other questions. For this question, you can divide by 3. See the remainder, divide by 5, remainder should be 3. So these two are out. Check out these two, one of these answers. Just substitute from answer choices, get the answer. Far simpler, far easier. That's what we should do. And I'm doing by this method so that it becomes a standard thing for other questions. Set X of 20 pipes can fill 70% of a tank in 14 minutes. So X 20 pipes fill 70% in 14 minutes, or it can fill 100% in 20 minutes. Nice. Another set of Y of 10 pipes fill 3/8 of the tank in 6 minutes, or fills one full tank in 6 into 8 by 3 minutes, which is 16 minutes. Nice. So far so good. The third set of pipe Z of 16 pipes can empty half the tank in 20 minutes, or can empty full tank in 40 minutes. Nice. So 20 pipes X, the 20 pipe X combo can fill a tank in 20 minutes. The 10 pipe Y combo can fill the same tank in 16 minutes. The 16 pipe Z combo can drain a tank in 40 minutes, drain the full tank. Right. Nice. So we can find how much one pipe can do of X type, one pipe of Y, one pipe of Z, 8 pipes of Z, all combos we can do. Right. Let's do, if half of the pipes of set X are closed, half are closed. So instead of 10, 20 pipes, we have only 10 pipes. And only half the pipes of set Y are open. Instead of 10, we have only 5. And all the pipes of Z are open, all 16 are open. Then how long will it take to fill 50% of the tank? 20 pipes take 20 minutes, 10 pipes will take twice the time. So this system, this number of pipes, it can, for a full tank, this will take 40 minutes. 10 pipes can fill in 16 minutes, 5 pipes will take 32 minutes. 16 pipes will take 40 minutes, 16 pipes are there, 40 minutes. Or this system of half of X, half of Y and entire Z, in 1 minute, they can fill 1 by 40 of the tank plus 1 by 32 of the tank minus 1 by 40 of the tank. X will do 1 by 40, the system of X. System of Y will do 1 by 32. All 16 of Z put together will do 1 by 40, but taking it away, Z's drain pipe or this whole thing put together, they can fill 1 by 32 of the tank every minute. Or this whole system, to fill a tank, it will take 32 minutes. How long will it take to fill 50% of the tank, half the tank? It will take 16 minutes. A solid cube is painted yellow on all its faces. The cube is then cut into 60 smaller but equal pieces by making the minimum number of cuts. Which of the following statements are correct? Very interesting. Okay. A solid cube like this. Nice solid cube. Cube is then cut into 60 smaller but equal pieces by making the minimum number of cuts. Right? So first of all, I didn't understand how do we make 60 smaller pieces. I thought we're cutting it into small cubes. If I can make it into 8 small cubes or 27 small cubes, all identical. I could think like that. And so remember, he's saying equal pieces. The pieces need not be nice cubes. They could be, but they need not be. A solid cube is painted yellow on all its faces. The cube is then cut into 60 smaller but equal pieces by making the minimum number of cuts. Right? Initially, I was like, how can you create a number of pieces that are not cubes? They are not taking a cube and breaking it into subsequent cubes. But breaking into subsequent equal pieces, not necessarily cubes. Very interesting. How can I do this? I can make cuts like this. If I make one cut, I'll get two pieces. If I make two cuts, I'll get three equal pieces. If I make three cuts, I'll make four equal pieces. If I make five cuts, I'll get six equal pieces. So if I make 59 cuts, all vertical, I'll make 60 equal pieces. Starting off with. But what we're doing here, this is a very not efficient process. Each cut is only one surface. What if I do cut once like this, two pieces, once like this, four pieces, then this and this, then like this, 8 pieces. With 3 cuts, I can get 8 pieces. Because if I make cuts only in one axis, I add one piece. If I cut like this, and then I cut like this, and so then I'm slicing something that's already been cut. My one cut results in more than one additional piece. Very interesting. So I can say, hey, I need to create 60 equal pieces. Instead of 59 cuts, I can make 29 cuts. And one cut like this, I'll get 30 into 260 pieces. 29 vertical cut like this. Saying, no, I don't want to do that. That's too simple. What if I said, if I keep making cuts like this, I make 9 cuts like that, 10 pieces will be there. One cut like this, 20 pieces. 9 like this, 1 like this. 2 cuts like this, 60 pieces. 9 plus 2 plus 3. So what am I doing? I can think of 60 as 60, 59 cuts. I can think of 60, oopsie, 30 into 2, 29 cuts like this and one more like that. Or I can think of 60 as 10 into 2 into 3, 9 cuts like this, 1 like this, 2 like this. I want to achieve this with the minimum number of cuts. So factorize 60 such that the factors individually are not large numbers. So if I factorize 60 as P into Q into R, the number of cuts I need to make is P minus 1, Q minus 1, R minus 1. P into Q into R, 3 axes, vertical and horizontal there are 2, front to back, left to right. And so P into Q into R, the number of cuts will be P minus 1, Q minus 1, R minus 1. So how can I write 60 as? 60 definitely has a 5 in it. So I can think of 60 as 3 into 4 into 5, as close to each other as possible. So the sum shrinks. Nothing else is going to come close to it. I have to have a 5. If I don't have a 5, I need to have a 10. 10 itself will be 9 cuts. Right? 3 into 4 into 5. So I'll need 2 cuts like this, 3 cuts like this, 4 cuts like this, 2 plus 3 plus 4. With 9 cuts, I can achieve this. Fewer than 9 impossible. I can already sense it. Right? Which of the following statements are correct? The minimum number of cuts is 9. Yes, that is true. 3 like this, 4 like this, and this, and 2 like this. So I can make 60 equal pieces. Each of those equal pieces, mind you, they're equal, identical cuboids, not cubes. Right? The number of smaller pieces which are not painted on any face is 6. Oh, this is very interesting. So I take this cube. And then I'm cutting 1, 2, 3, 4. 1, 2, 3, 1, 2. And so, how many faces will have no surface painted? So, if I make 2 cuts here, let me make 2 cuts here. So, let me think about how I can show those 2 cuts. So, I am making 2 cuts here, slicing like this, right? And then, what am I doing? I'm then saying, hey, nice, I'm making 3 cuts vertically like this, or I cut like this, I can cut like this. Let's say I put 3 cuts like this, 1, 2, 3, and then I make 4 cuts vertically. What color can I choose? I'm going to go with a bright blue. Nice. It's tough to imagine, but give it a go. Now, mathematically or visually, if I make 2 cuts like this, think about it like this. Any piece here will have something painted. Anything on the boundary will have something painted. So, all of these will have something painted. All of these will have something painted. Likewise, boundary, all of these will have something painted. All of these will have something painted. Here, here, everything on the boundary will have something painted. And so, if I am making 3 cuts or 3 pieces, this side and that side will have something yellow. If I am making 4 pieces, the 2 boundaries will go off. 5 pieces, the 5 boundaries will go off. The 2 boundaries will go off. And so, think about this. I have a piece, I am making 5 slices. The leftmost slice, rightmost slice will have the boundaries painted, kick them out. I am making then 4 slices, 1, 2, 3, 4. This and this out. Then I am making 3 slices, 1, 2, 3. Top and bottom I have to remove. So, how many equal pieces will not have anything painted at all? I will have to think about. From here I remove 2, from here I remove 2, from here I remove 2, 1 into 2 into 3, 6 pieces. Imagine this is the innermost cuboid. What is sitting inside? The big cube is like this. I remove boundaries, I remove boundaries, I remove boundaries. What is sitting inside? That's a 1 into 2 into 3 cuboid, 6 pieces. Right. So, the number of smaller pieces which are not painted on any face is 6. That's correct. Both of these are correct. Statement 1 is correct and statement 2 is correct. Team X scored a total of n runs in 20 overs. Team Y tied the score in 10% fewer overs. So, X scores in 20, Y scores the same runs in 18 overs. Had Team Y's average run rate been 50% higher, the scores would have been tied in 12 overs. How many runs were scored by Team X? And so, let's say the total runs scored were n. Average run rate is n by 18. Average run rate. Nice. Average run rate for X would have been n by 20. Right? So, Team Y tied the score in 10% less over, fewer overs, n by 18 would have been the run rate. If Team Y's average run rate had been 50% higher, right? So, new average run rate is n by 18 into 3 by 2. 50% is 0.5, 50% higher is 1.5, 1.5 is 3 by 2, which makes this n by 12. If Team Y's average run rate were n by 12, the scores would have been tied in 12 overs. Average run rate is n by 12 into 12 is n. The scores would have been tied in 12 overs. Yeah, that's correct. How many runs were scored by Team X? What is n equal to? So, Team Y scores in 18 overs. If the run rate were 50% higher, they would have scored this in 12 overs. Or in 12 overs, they would have tied this. 10. It's got nothing to do with n. N by 18 into 1.5 is n by 12. Always. For all values of n. Or what is the value of n? It cannot be determined. 3 prime numbers p, q and r, each less than 20, are such that p minus q is equal to q minus r. And so, I'm going to write it the other way around. P, q, r. P minus q is q minus r. This difference is equal to this difference, or r, q, p form an arithmetic progression. Right? So, it's an arithmetic progression. We have p, q, r are all distinct, right? And each of them less than 20. And RQP is an AP increasing AP. Not necessarily increasing AP, P minus Q is equal to Q minus R, it can be the other way around, but doesn't matter. We are looking at 3 prime numbers in arithmetic progression such that all 3 are less than 20. And so, obvious thing, starting point for all of this is put the smallest prime number 2 in there. And so, if I start with 2, this is an odd number, this is an odd number. That means the common difference should be an odd number. 2 to 3 you add 1, 2 to 5 you add 3. To an odd number we add the same common difference. That will become even. So, 2 is not part of our AP. 2, 3, 4 is an arithmetic progression. If 2 is part of if the starting point of this arithmetic progression, first term, the middle term has to be odd, with only one even prime number is there. That means the last term will be an even, that cannot be a prime number. So, 2 is not our starting point. Best starting point after 2, 3. So, see 3, 5, 7 picks itself. 3 plus 2, 3 plus 5. So, then we say 3, 7, 11, that works. 3, 11, 19, this also works, we are on a roll. And so, 3, 5, 7, 3, 7, 11, 3, 11, 19, all 3 satisfy this condition. All 3 primes are less than 20, then arithmetic progression. RQP, beautiful. I know straight away that we cannot think about 3, 13, 23 because one number will be more than 20. So, including 3 in the sequence, the 3 primes, 3 sequences. With 2, there is nothing possible, that is kicked out. Next, what do? We say first term, smallest term, let it be 5. 5, 7, 9 does not work. 5, 11, oops. 5, 11, 17, that works. Brilliant. 5, 11, 17 plus 6 plus 6, that is a sequence, all 3 numbers are prime. 5, 13, 21, it will become not possible. 5 plus 8 is 13, 13 plus 8 is 21. 21 is not prime and we go beyond 20, so that is ruled out. Starting with 5, there is only one sequence, we are done. Then we start with 7, 7, 11, 15 does not work. 7, 13, 19. 7, 13, 19 works. 7 plus 6 is 13, 13 plus 6 is 19. Brilliant. So, 7, 13, 9, after this we do not have to worry about. 7, 17, 27 and all we do not have to worry about. 7, 13, 19 works, nice. Starting with 7 is the only possibility. Then we go to 11, starting with 11, 11, 13, 15 not possible, 15 is not prime. 11, 15, 19, 15 is not prime. 11, 17 we spill over. Starting with 11, nothing is possible. 13, 13, 15, 17, no. 13, 17, something, no. Starting with 17, 17, 19 and then we are out, nothing else. So, 1, 2, 3, 4, 5 possibilities. How many distinct possible values can we get for P plus Q plus R? Remember, this is not PQR, it is P plus Q plus R. Maybe 2 of these fellows have the same sum. We will have to worry about that. Let's think about this. 3 plus 5 plus 7. These are terms in arithmetic progression. So, the sum of them will be 3 times the middle term. 3 plus 2 is 5, 7 minus 2 is 5. Adding all this is 15. Adding all this will be 21. 7 into 3, 33, 11 into 3, 33, 11 into 3, 39. 3 plus 7, 10 plus 11, 21. 14 plus 19, 33. 16 plus 17, 33. 20 plus 19, 39. How many possible values are there for P plus Q plus R? Only 1, 2, 3, 4. P plus Q plus R can take only 4 values, although there are 5 possibilities for PQR. Brilliant. A tram overtakes 2 persons X and Y walking at an average speed of 3 kilometers per hour and 4 kilometers per hour in the same direction and completely passes them in 8 seconds and 9 seconds respectively. So, there is an X here, there is a Y here, there is a tram that crosses X, tram then crosses Y. X is walking at 3 kilometers per hour, Y is walking at 4 kilometers per hour. They're walking in the same direction. Tram is also in the same direction. Right? So what are we doing here? When I'm overtaking a person, what is the definition of that? I think about the tram being behind X to the tram going completely ahead of X. Right? So the relative distance covered is length of the tram. Relative speed, suppose the speed of tram were x kilometers per hour. Relative speed is x minus 3. Length of tram by x minus 3 is 8 seconds. Yeah, I know what all of you are thinking. This may be in meters, this is in kilometers per hour, that is in seconds. We'll come to that. So this is in seconds, so we'll have to figure that out. So L by x minus 4 is 9 seconds. We'll have to account for the units. This is in kilometers per hour, this is possibly in meters. Meters by kilometers per hour, how is it going to be seconds? Yeah, we'll come to that. I'm not saying that's the answer, but here we'll come to that. We'll have to process that. Now, I don't want to process that in the first step. I want to divide this by this, L will disappear. X minus 4 by x minus 3 is 8 by 9. Whatever might have been the appropriate units here. We have a units called kilometers by meters into seconds, legitimate unit. Fine. So you could have some fudge unit like that, but I don't care. Once I divide, the unit problem goes away, and I have this. With this, I can find x in kilometers per hour. So 9x minus 36 equals 8x minus 24, or x is 36 minus 24, which is 12 kilometers per hour. Brilliant. Now there is a tram that travels at 12 kilometers per hour. What is the length of the tram? Now, if L by 9 kilometers per hour, it can cover in 3 seconds. Length of train at traveling at 9 kilometers per hour, this may be in meters, gets done in 8 seconds. Not to worry about the units, we'll come there. Our length is 8 seconds into 9 into 5 by 18 meters per second. I know how to go from kilometers per hour to meters per second, multiply by 5 by 18, I'm done. So this is 1 by 2, 4 into 5, 20 meters. I'm not saying we don't need to worry about the units, we need to. We have to think about kilometers per hour, go to meters per second, and then think about meters and seconds, length in meters and time in seconds. But the speed is in kilometers per hour. So go to the meters per second world. That is correct. We need to do it. But at the first step, when we're doing the ratio, x minus 4 by x minus 3 is 8 by 9. I don't need to care about the units. Find x. X is in kilometers per hour because these two are in kilometers per hour. Otherwise, I cannot subtract. So I get x is 12 kilometers per hour. Now to find the length, I go back to the meters per second speed. The difference between some two natural numbers is 10. What can be said about the natural numbers that are divisible by 5 and lie between these two numbers? Difference between two natural numbers is 10. So we're thinking about 1 and 11, or 5 and 15, or 2 and 12, or 103 and 113, something like this. What can be said about the natural numbers which are divisible by 5 and lie between these two numbers? Between 1 and 11 and divisible by 5, we'll have 5 and 10. Between 5 and 15 and divisible by 5, only 10. Between 2 and 12, we'll have 5 and 10. Between 103 and 113, we'll have 105 and 110. So there are between two numbers that are separated by 10, there are 9 different numbers. It could so happen that there's only one multiple of 5, or there could be two multiples of 5. And it could be only one, or there could be two. We cannot have 3. In 9 consecutive integers, we cannot have 3 multiples of 3. We cannot have 0. If you have 5 consecutive integers, there will be a multiple of 5. If you have 9, there will definitely be 1. There cannot be more than 2. 1 or 2. There's only one such number, not required. There could be 2. There are only 2 such numbers. No such number exists. No. Only 2 such numbers. No, sometimes there could be only 1. There can be more than 1 such number. Yes. There could be 1, there could be 2. 2 numbers are possible, 1 number is possible. What is the unit digit in the multiplication of 1 into 3 into 5 into 7 into 9 into all odd numbers? It's a super question. After a bunch of difficult questions, this question is like a freebie. And bunch of odd numbers. So the product has to be an odd number. Product is odd. So the unit digit can only be 1, 3, 5, 7 or 9. Nothing else is possible. The unit digit cannot be an even number. It's a multiple of 5. 1 into 3 into 5 is 15. Into 7 will end in 5. Into 9 will end in 5. Into 11 will end in 5. 5 into any odd number will end in 5. We know that. A multiple of 5 will end in 5 or 0. If it's even number, it will end in 0. If it's an odd number, it will end in 5. An odd number ends in 5. Done. X can complete 1/3 of a certain work in 6 days, or X can finish in 18 days. Y can complete 1/3 of the same work in 8 days, 24 days. Z can complete 3/4 of the same work in 12 days, 3/4 in 12 days, full work in 16 days. 12 into 4 by 3. 75% can be done in 12 days, entire work in 16 days. Nice. All of them work together for n days, and then X and Z quit, and Y alone finishes the remaining work in 8 2 by 3 days. Pain in the neck. 8 2 by 3 days. 8 into 3, 24, 26 by 3 days. In a typical fashion, we can try to define the total task in terms of number of units, which happens to be an LCM of 18, 24 and 16. 18 and 24 LCM is 72. 72 is 8 into 9. This is 16. So 16 into 9 will work. Or let us say the task involves 144 units of work, of which X in 1 day can do 8 units, 144 by 18. Y can do 6 units, 144 by 24. Z can do 9 units, 144 by 16. All of them work together for n days, and then X and Z quit, and Y alone finishes the remaining in 8 2 by 3 days. So all of them work together for n days. In 1 day totally they can get done 23 units of work. So in those n days they do 23 into n, that many units of work. Apart from this, Y works for 26 by 3 days, finishing 6 units per day, plus 6 into 26 by 3 is equal to, the whole task now gets finished, which is 144 units of work. This by 3 is 52. So 23n equals 144 minus 52, which is 92. Ooh, I'm very happy. 23n is 92, n is 4. Nice and simple. Thank you for watching. Check out the course details here.